For the rest of the section, I'll really encourage you, try these out on your own, see if you can find the right match in the table, and then watch the video just to check and see if you did it right. Or maybe if you get stuck, check the video to get unstuck, and then try to finish it on your own. Okay, this is a section where I'm not really teaching you many new skills. We're just practicing one single skill, which is using Appendix B to try to solve our integrals. So go ahead and pause this video and try it out, then unpause and see if we do the same thing. So looking at our Appendix B, I'm just going to go through the list until I see something that looks like a good match for this. Okay, it doesn't really look like a function raised to a power, or a plus bu, or a quadratic term, or a square root, or a sum or difference of two squares. I don't have a square root, I don't have a square root, no sine or cosine or tangent. Eventually I stumble on this guy. I do have e raised to some function. So let's just look in there and see if we see something nice. Okay, so looking at this one, I'm supposed to have my e on the bottom of a fraction. The only one that really matches that is number 84. So let's grab number 84 and see if that works well. Okay, so I'm going to move this up here, make it a bit bigger. See if I can get an exact match for that. Now, if this is going to work, then u needs to be negative x squared. Okay, I'll go ahead and find du just in case I need it later. It's negative 2x dx. And because I'm going to need to substitute for dx, dx equals du over negative 2x. Okay, so let's plug everything in and see if we can convert this all to look exactly like that. So I've got x over 1 plus e to the u. And then for dx, I'm going to write du over negative 2x. So if I simplify this, I'm going to bring out that negative 1/2. I've got negative 1/2 times the integral of du over 1 plus e to the u. That is exactly what I wanted. Okay, notice they had a 1 on top, so sure, I could write it this way as well. So now I have exactly what they had, just with a coefficient out front, which is okay. So because I have an exact match, I can use the formula. When you do your homework for this section, tell me which formula you're using. Say, hey, I'm using number 84, just so I know what you did in the back of the book. All right, so let's follow the formula. I'm going to plug everything in. U, that's negative x squared, minus the natural log of 1 plus e to the u plus c. Okay, now honestly, I'm not going to worry about the plus c until the end of my problem. So let's hold off on that for now. This becomes x squared over 2 plus 1/2 natural log 1 plus e to the negative x squared. And now I'll add on my plus c. Okay, but notice I was actually supposed to do a definite integral. So now that I've gotten this, let's take what we have and evaluate it from 0 to 2. Okay, so that means I'm going to start by plugging in 2. And then I'm going to plug in 0. So let's see what that gives us. 2 plus 1/2 natural log of 1 plus e to the negative 4 minus 0 plus 1/2 times the natural log of, let's see, that's going to be 1 plus 1, which is 2. All right, well, we can clean this up just a little bit. So I've got 2 plus 1/2 natural log of 1 plus e to the negative 4 minus 1/2 natural log of 2. So you could leave it like this, or you could go ahead and combine those logarithms. So if you want to combine the logarithms, you can use the power property and then the quotient property. Okay, so this is probably the most simplified answer we can give here. But once again, all I had to do was find something in the table that looked like it. So I found the right category, I found the right formula, I converted everything to look exactly like the formula, and then I just plugged things in until I got to the end.